Everybody, welcome to Video Notes 10.1. We're going to look at characteristics of acids and bases, strong and weak acids, acid concentration, indicators, pH, and that's it. So go ahead and look at the book connection. So chapter 16, sections 1 and 2. Try self-check 16.1 really. All right, it's going to be easier to do after listening to this, and you know what Moltedo always says. So properties of acids. So the part of an acid that makes it an acid is an H+, which is the same as H3O+. It's what gets you when you're thinking about acid. They taste sour in general. They react with metals and marble carbonates. They change blue litmus paper to red. They have a pH less than 7, and they're often can be found in juices from foods. So what are some acids in everyday life? Well, muriatic acid is used to clean stuff outside. Lemon juice, vinegar, battery acid, right? Here's an example of how blue litmus paper turns red with a drop of acid, blue to red acid. So, if you look at this base, you're probably thinking, hey, that looks sour. If you look at that, it's yucky. We're going to say bases taste bitter. Okay, so properties of bases. The part of a base that's what gets you is the OH-. So hydroxide is a characteristic of base. Tastes bitter. All right, it reacts with organic material and denatures proteins. Changes red litmus to blue, so it's the opposite of acids. They're slippery, pH greater than 7, often used in cleaners, and you might have heard of Drano, milk and magnesia, antacids, and bleach and other cleaners. So red to blue, base for you for litmus. So there's several definitions of acids. One of our working definitions is going to be the definition that was determined by Arrhenius. Arrhenius acid is a substance that, when added to water, increases the concentration of H+ ions. Look, it's HCl. When you put it in water, it picks up into H+ ions, hydrogen ions, and chloride ions. Okay. Or you could even look at it this way: HCl, when it breaks up, when you put it into water, it turns into H3O+ and Cl-. All right, you might be saying, what's the diff, Harbin? All right, so HCl, when you put it into water, is never really by itself. It's always attached to a water molecule. So H+ and H3O+ are really the same thing, because you never have H+ not attached to a water molecule. So this means hydrogen ion. Okay, so how's that different than an Arrhenius base? So this is a definition that when you add an Arrhenius base to water, it increases the concentration of hydroxide ion. Hydroxide, don't you forget it, OH-. Oh yeah. All right, I'll stop. So when you put sodium hydroxide into water, and you should be used to this from the last chapter, you get Na+ ions and OH- ions. So sodium hydroxide is a base because in water it produces hydroxide ions. All right, that's one definition. Acids make H+ in water, and bases make OH-. Here's another definition. Okay, this is a Bronsted-Lowry definition of acids and bases. According to the Bronsted-Lowry theory, acids are H+ givers and bases are H+ takers. So let's see how that works. Here's a chemical reaction. Well, a substance going into water. It's going to turn into H3O+ and Cl-. You might be saying to yourself, "Self, we just saw this." You did. So if you go from here to here, what did the HCl do? Gives away H+, going left to right. So that's an acid. What does this substance do? Takes on H+. Right? So that means H2O is acting like a base in that case. You can go backwards in the opposite way too. So an acid turns into what's called a conjugate base. Conjugate base. It's the result. And then a base turns into a conjugate acid. Conjugate acid. All right, so there's four things here. There's the acid and the base on the left, and its conjugate on the right. Okay, let's look at this one. This is gonna turn into NH4+ and OH-. Okay, so let's see what the NH3 does. Okay, takes on H+. That means this is a base. H2O gives away H plus. What? Water? Now it's acting like an acid. So water is multi-purpose, right? So a base turns into a conjugate acid, and an acid turns into a conjugate base. I'm going to leave the last one. You could try it, but we'll do it in class. Okay, so definitions. We have the Arrhenius acid is gives H plus in water, and Arrhenius base takes or gives OH in water. Bronsted-Lowry acids give H plus, bases take H plus. So a conjugate acid is what the base turns into. Conjugate base is what the acid turns into. Okay, but you can read in the opposite direction, and one's an acid and one's a base. Okay, just to refresh your memory on naming acids, I ate it, it was icky, and then I got the itis. I'd use hydroic, yeah. Okay, so the anion is chloride here, and so then you'd use hydrochloric acid to name it. Okay? Keep that in mind. We did it before. It's just a refresher. Hey, look, here's some examples. So if you see the prefix hydroic acid, you know it came from an IDE anion, okay? And then H plus and I minus make HI. Oh, it's a friendly acid. Okay, I'll pick this one. HNO3. Hello, I'm an acid. I start with hydrogen. And this is nitrate. And so then you would ate it. It was icky. So this is nitric acid. Okay, there's a ton of them to practice here. You'll refresh your polyatomic ions. You'll find some stuff you need to know. So practice those. Okay, so now we're going to talk about classifying acids. So there are strong acids, and there's 6 of them that you have to memorize. So I'm just giving you the formulas here. You should probably write out the names. Memorize these. All right, 6 of them. What makes them strong? Well, they ionize 100%. That means if you put HCl in the water, you don't get HCl stuck together. You get 100% H pluses and 100% Cl minuses. So if I had 3 molar HCl, right, concentration of 3 molar. 3 molar HCl. What does that mean? Well, since this is going to break up 100%, it means the concentration of H plus is 3 molar. Okay? Because HCl is going to turn into H plus and Cl minus 100%. So if I start 3 molar of this and all of it turns into H plus, then I'm going to get 3 molar H plus. Right? That goes for all of these strong acids. The concentration of the strong acid equals the concentration of H plus. If you see an acid on a paper, you know it's an acid, starts with hydrogen, but it's not one of these 6, then we call it weak. And that means it does not ionize very much. It pretty much stays together. Strong bases. Well, same concept of being strong is that it ionizes 100%. So if you have NaOH, and I have 4 molar NaOH, that means I have 4 molar OH minus. So the concentration of the strong base, because it's going to ionize 100%, is going to be equal to the concentration of hydroxide. Okay? So how do you know if it's a strong base? Well, you look at your periodic table. Groups 1 and group 2 with hydroxide makes a strong base. So if you see CaOH2, you're like, oh, group 1. I'm sorry, I said group 1. Group 2. This is strong. Right? But strong just means that it breaks up 100%. What if you see AlOH3? You're probably saying to yourself, so that looks like a base, but it's weak because Al is not here. Oh, whoops. No. Al, no, so this is weak. All right, the most common weak base you're going to find is NH3. All right, naming Arrhenius base formulas for hydroxide bases. NaOH, name the first part sodium, name the second part hydroxide. Okay, if you see the formula of a base, you look at that, Ba plus 2 from the PT. Okay. Hydroxide is OH minus, so we need 1 barium and 2 hydroxides to make a neutral compound. Okay, concentrated versus dilute. Okay, concentration is this equals capital N. So concentrated acids or bases have a high molarity. We're going to say 1 or greater. It's going to be concentrated. 1 molar or higher is concentrated. Okay, so what does dilute mean? Dilute means that it has a low molarity. So here you go, less than 1 molar is dilute. Okay. So it doesn't even have to be an acid or a base to be concentrated or dilute, but it's all about the molarity. Molarity, molarity. Concentration, molarity. Concentration, molarity. Say it right, say it right. Okay, be careful. We talked about strength and we talked about concentration, and they are not the same thing. 12 molar, that is concentrated. Look at 12 molar, molarity equals concentration. Right, so this is high molarity, so it's concentrated. Concentrated. Right? Over here we have dilute. Why? Low molarity. Okay. Acid starts with H. Strong, because HCl is one of the super 6. Super 6. Right, that means it ionizes completely. So you're going to get H plus and Cl minus 100%. Okay. This is also strong. Strong. It's HCl again, but it's dilute. Okay. Indicators. Hey, litmus. Litmus is an indicator. It's the litmus test. All right. But indicators are equilibrium systems. Right? So if we use Le Chatelier's principle, see how this works. Acids are H plus givers, right? Givers. So if you put something into litmus, blue litmus, all right, add more, it's going to shift left. So what's going to happen to litmus? Litmus turns red. Red. Right? What if you add OH minus? Well, OH minus is going to grab this and take it out, so it's going to shift to blue. Yay! All right. Aw, that's silly. Silly and funny. Okay. Phenolphthalein is an indicator. You used it in the lab. All right. Add more H plus. Acid is added. All right. Add more H plus. Stress. Here. Shift left. All right. So the phenolphthalein is going to go clear. Clear. If you add base, OH minus, pulls out. H plus. And so shift base turns phenol, blah, blah, blah. Tinker. Okay. All right, so indicators. Look at how many different indicators there are, and these are the names of them. Methyl violet, thymal blue, methyl yellow, bromophenol blue, methyl orange. These are all organic molecules that change color based on equilibriums with acid and base. All right, so what does that pH mean? Over here we have pH. Here's neutral. All right, and then up here is base, and down here is acid. So what is that pH really measuring? Okay, well, pH is the opposite log of the hydrogen ion concentration. And so that means if we want the hydrogen ion concentration, we need to know the pH. So these are memorize these formulas we're going to be using. Memorize. But it just, pH is a way to relate to how much H plus is in the solution. Okay. So if an indicator helps us determine the pH is 1.3, what does that mean about the substance? Well, 1.3 is acid, less than 7. Okay. So what does that mean about H plus? Well, H plus, you have to calculate 10 to the negative 1.3. So the hydrogen ion concentration in that solution is 5.01 times 10 to the negative second molar. Okay, that means that's kind of a lot. of H plus means acid. Right? Okay. Well, what if you know the hydrogen ion concentration? How do you figure out pH? Well, you plug it in opposite log of 2.3 times 10 to the negative 8. Plug that in your calculator, and you get a pH of 7.64. All right, so this number is a lot smaller than that one, right? So what does that mean? That means there's a lot less H plus, and in fact, this is just basic, less greater than 7. Okay, so if there's less hydrogen ion, it's probably going to be base. If there's a lot of hydrogen ion, it's going to be acid. Right? So that's what pH is trying to tell us. All right, look at this pH scale. There's a couple of things you might recognize. You got your water, neutral. Right? You got drain cleaner and ammonia. Those are bases. Milk is slightly acidic, although milk can change because over time it changes its chemistry a little bit. Oh, look, an apple is acidic, and then you have your hydrochloric acid. Okay. So to review, 2 ways we describe acids and bases. Arrhenius is, well, I'm an acid, I have H plus. I'm a base, I have OH minus. Bronsted-Lowry is in terms of acids are H plus givers. Bases are H plus takers. All right. Acid. H plus giver has a conjugate. A base has a H plus taker with a conjugate. Right? Acids and bases have different properties. Make sure you know those. Strong means the acid or base breaks into ions. Weak stays together. Concentration is molarity. High molarity. Dilute is low molarity. And then indicators tell us pH. And we need to know these two formulas. All right. So, hey, there's Moltato again. Hey, Moltato, did you do the self-check? I sure did. Yeah, folks. That was Moltato talking, as you can tell. All right, so peace out, do the self-check, look into this to see if you agree, all right? Have a good one.